Welcome back. In the previous lessons, we've endeavored to set ourselves up for success by adjusting our mindset, understanding our role in the company with the expectation of different stakeholders. We've addressed providing value. We've positioned ourselves when a project proposal or plan was handed to us. In this lesson, we will take the conversations with the client and turn them into a problem statement first, and expand on the statement to generate a project proposal. The proposal that you provide in your company will definitely be company specific, but in this lesson I will include some very handy insights. So let's get started. The points we will discuss will include the difference between academic and consulting problems, the problem statement, project phases, identifying the required data and assumptions, detailed scope of work, and planning before execution. I imagine by now you have become aware of the fact that clients very often don't have a good definition of what they want. They have a general idea, a feeling, but it's very seldom an engineering brief that you are accustomed to getting while studying. As you progress through the ranks, it becomes more and more your job to generate this engineering brief. Your ability to break problems into structured steps will define your success. So, we will talk about how you can do this. First, we will discuss the problem statement. What does the client say that they want? What does the client think that it will take? And when will the client be happy that their need has been met? Now, we define the constraints that exist, which may have been defined by the client, or it may come from your engineering insights, knowing that certain solutions are not possible. It is useful to have the stakeholders named in your project proposal and project plan because you can internally, meaning not client-facing, work on managing communication with different stakeholders. Some people need to be told certain things, some people need to not be told certain things. Say the client said that their gearbox broke. They want to replace this broken gearbox, but they need to know why it broke to ensure that the new one does not experience the same fate. You might say something like, client has approached company to conduct a root cause of failure assessment on the specific gearbox installed at this site, which failed on this day. A replacement of the gearbox is to be fitted at this date, and the root cause of failure will determine the course of action in this regard. The money comes from this guy, and you will share impactful income in non-technical terms with this guy at a very high level. The technical guy is the contact person and needs on-the-ground knowledge curated for company reputation building and project success. Now, we break the solution into the phases that need to be completed. I like to do this, starting at the end. We need a root cause of failure. This means we will need to draw up a root cause of failure diagram. To have this diagram, we need to know all the different ways that the gearbox could have failed. We need to know what requirements exist on every level. These could be loading or regulatory requirements. We need to know what actually happened to the gearbox, like the loading it saw and the conditions of operation. We need to know what the gearbox looks like, because the root cause might be staring us in the face. Each of these lovely phases have some data that is required, which we can set out in broad strokes. Very quickly, we might identify failure methods that we should know, the regulatory body recommendations, the functional analysis method for a gearbox, and some visual inspection good practice. Additionally, we will need some information from the client that we could start compiling into a list to be communicated to the client. It is good practice to compile the list of required information for the client before the project commences, because often the first stage of the project is to review this information. So, while you're creating the project proposal, you generate the request of information as well. As we are engineers, there are some information that we may not explicitly need from the client, because some other information that they would have available may guide us to make informed assumptions that can be supported by engineering best practice, like the lubrication requirements of a gearbox. If you know the gearbox that they're using, and the application of the gearbox, then you can find the lubrication requirement. I found it extremely useful to take these project phases and require data and generate a scope of work from it. At each phase in the project, you set out what will be done, how it will be done, what resources will be used, and what information will be needed. You may allude to assumptions made as well, just to communicate to the client what you intend to do. Maybe they might provide more information or confirm that assumptions are acceptable. But along with all of this, the input in the phase is noted. The output of the phase is noted, and the risks associated with the phase is noted. The mitigating actions are yours as project engineers to note in your own project brief and task or project management methods. Creating a project plan or proposal is a very high-level thought exercise. You get into the nitty-gritty of what the project entails, but you do not actually execute the project. It is a difficult skill to hone, to traverse the line between planning and actually doing. But success in this step will make success in projects and business-minded execution so much easier to attain. So, set out to use structured problem-solving frameworks, understand the project requirements and assumptions, and detail the scope within which you can operate in executing the tasks. These boundaries make it possible to underpromise and overdeliver, which is good for business. All right, now you know what to do. I have included a template that you can use to prompt you when you are working on your project proposals in the worksheet. You can execute the activity in the worksheet as a first trial, taking what we've discussed in this lesson and applying it to a hypothetical engineering problem statement. Let's get to it.